All righty, what's going on, everybody? We are live this morning. Tell your friends, tell your kids.
Live and alive.
Dan is celebrating a Tampa Bay Lightning victory. Dan, how does it feel to cheat your way to victory?
We're not cheating. We're just skirting around the intent of the rule. But how do I feel, Taylor?
Yeah, how do you feel, Daniel?
That's how it feels.
Awesome. Y'all, we're very excited to have my dear friend, Tim Dobbins, with us this morning. Tim, thanks for hanging with us today. I appreciate it.
Hey, I appreciate it. Happy to talk about machine learning, natural language processing, always.
Yeah, super nerdy stuff. So I'm glad you're doing it, not us.
Oh, yeah.
So we were talking about barbecue. So for those of you tuning in, we were talking about barbecue. I'm interested to hear your thoughts. Again, add us, comment us. Let us know where you're tuning in from. I know Tim would love to see your beautiful faces. We would as well, but obviously we see them a lot. We're talking about barbecue, and I'm interested. Y'all kind of chime in on barbecue. Tim, do you have a favorite? And I want to say this, right? So we got Carolina barbecue, which is different, right? So North Carolina is different from South Carolina. South Carolina barbecue is the absolute best barbecue there ever is. Don't at me. Mustard-based barbecue. Tim, do you have a favorite at all?
So I can't go into the nuances of barbecue styles like I can Nashville hot chicken styles. And you would think there's only one sort of Nashville hot chicken style because it's all Nashville. But there are so many Nashville hot chicken restaurants in Nashville doing big things. And one of my favorites is the food truck. But
it's just called
it's called Hertz Hot Chicken. Go check it out. It's in Mount Juliet, Bellevue.
Shout out.
But we started talking about this because I think Taylor brought up Martin's Barbecue in Hendersonville, and somehow I mysteriously started following them on Facebook, and they offer a barbecue hot chicken blend, and my mouth instantly started watering. So I got to get some of that when I'm back in Nashville.
Yeah, absolutely. And then Tim, invite me because I want to come with you.
I got you.
All right, so let's go ahead and get rolling. We got some viewers, we got some listeners. So Tim, for the people, give us like your elevator pitch, 30,000-foot view of who you are real fast.
Name is Tim Dobbins from Nashville. I'm a Nashville native. Grew up in Madison. Parents still live in Madison. Obviously housing market is crazy. I can't even afford to move back to Nashville. But just moved to Chattanooga and started a role where I'm doing natural language processing full time. Within that, it's natural language understanding, natural language generation with chatbots and stuff. So that's really where I decided to go as a data scientist. There's so many different areas of data science to go. I really decided to tailor my career trajectory towards natural language processing because that's what I'm interested in the most.
That's cool, man. That's cool. And so let's dive in, Tim. And for those of you who are watching, feel free to ask questions, right? This show's a lot more fun when people ask questions. That's not me, Jake, or Dan. Tim, what is NLP and what is ML for people who are dumb like myself?
Okay, so natural language processing is a way to teach a computer how to determine what is being talked about. That's sort of the first phase of natural language processing. What is being talked about in a body of text? And the reason we want to know that is, say you're in a call center, you want to route a certain call based on information that has been spoken so far to a certain team that handles that call. Certain teams in a call center might handle very high effort requests. Other ones might handle very low effort requests. And then once you start to get to the areas of deeper automation beyond just routing calls to certain teams or getting this thing to that place, you start wanting to parse that body of text to determine the who, the what, the when, by how much, and really detect those entities within the text so you can then start to go from shallow automation, what I call, which is routing, getting things to the right places, doing cursory automation, versus the deep automation where, okay, you've done the routing. Now for example, the call is at the right team, but now you want to automatically resolve that request by parsing that body of text for the who, what, the when, the where, the how. And for example, I'll give a quick example. I'm in the insurance business. A lot of the requests that come in are, hey, John Smith was just terminated from, Acme. We need to release him from his coverage or update his policy. So that's a pretty easy request for humans. They can do it no problem in 5 seconds. But teaching a computer to do that, we can do it in milliseconds. And all we have to do is
right.
And it scales. So
yeah.
So you get 1 million requests coming in. We can do all those in 5 seconds versus a human doing, 1 million in probably the lifespan of their career. So now we're talking, okay, we've identified what it is that is being requested. It's a termination, a cancellation of coverage or something like that. Now we need to go into the text and parse out the text to detect the entities. John Smith, now we're looking for a policy number. Now we're looking at, looking up that policy number, and now what's called straight through processing to now go to the database itself and do that modification automatically, so a human doesn't have to get involved at all, and they can focus on more important work, more impactful work.
So was that just NLP? Like what's ML then?
So that was NLP. A lot of times you can blend NLP and machine learning.
Okay.
I would say machine learning at a very high level is a mathematical approach to dealing with uncertainty and learning from historical patterns and trying to really predict in that environment of uncertainty.
So if you're using NLP, will you consequently be using ML or not?
Not all the time.
Okay.
So a lot of NLP is focused on just counts,
Okay.
word counts. There's not to get too much into the details, but there's a technique called TF-IDF, term frequency inverse document frequency.
There we go. There we go.
And we're full on in now. Okay. We're in it now. So we're not going back. So that is based on using basic statistics about a body of text to essentially predict what is being talked about, let the modeler know what are the important words in a given document. And then you go beyond that and start using things like word embeddings, document embeddings to now create these knowledge representations of text. So traditional data, we're all familiar with traditional data. You open up an Excel sheet, you have numbers everywhere, right? Those numbers mean something. You can say, 5 relates to this thing by this much.
Do they mean something? Because it's all
most of the time they mean something, right? Yeah. And now you pull in the body of text, this piece of text that is John Smith needs to update his policy. Well, what does that mean to a computer? A human can read that, but it's not really computer readable. Gotcha. So we have word embeddings, fancy name for knowledge representations. Actually, I don't know which name is fancier. We'll go with knowledge representation. And that's a way for the person training the word embedding to assign this string of text. John Smith needs to update his policy. Some multi-hundred dimensional list of strings to now say, okay, we have an idea of what this means when compared to the rest of the body of text that we're seeing in our database and our system or whatnot.
So I have a question about the training of these algorithms and the training of these, right? So, we've built some chatbots with some help of some open source projects and off the source, but there's also a whole bunch of other custom stuff that has to go in on top of it. And some can be trained faster than others, I guess, based off of the nuances of really what you need it to do. But where did that kind of start, and how could you speed up the training of some of these as needed? Yeah. And what does that look like? Let's use a chatbot for example, right? Because I know there's like tons of edge cases we could go down that rabbit hole. Mm-hmm. But like let's use a chatbot for HR functions.
Mm-hmm. So yeah, I mean these systems are actually not as new as we like to think. We hear about them a lot now because we have computers that can actually practically implement these things. But a lot of these systems have been around for a long time. We have new techniques to make them faster, make them smarter. But these have been around for quite a while, and they're just getting more sophisticated. So let's take chatbots, for example. Chatbots is a very hard problem when you go beyond a basic business problem. So for HR, give me a request for HR. Is it like, we're hiring an employee and they need to have, they need to be paid this much or whatnot, or something like that, right? So for a chatbot, if we're doing this at scale using a chatbot, then like with some self-service, IT requests, then I imagine something like that's pretty easy because you don't really have a lot of parameters when you start the conversation. There's only so many things you can talk about. So when you have a situation like that, where at the start of the conversation, there's only so many different avenues a conversation could go down, and within each avenue, there's only a few parameters that you need to then automate that request. That's pretty doable nowadays with chatbot platforms like Rasa, like Amazon, AWS Lex. Google just released a new chatbot called Lambda. I haven't really messed with that, but I hear a lot of good things. So when doing requests like that, where the parameters are minimal, and the number of different avenues the conversation can go down, those are pretty easy to solve today. But companies get in trouble when they try to automate some of the deeper tasks that really involves a lot of human knowledge. At my company right now, we're trying to lay a framework for creating chatbots using AWS Lex and Rasa. We're trying to create that framework to determine what can be automated now, or what can be fully automated now, and what can sort of be like shallow automated. Those requests, that's like, say in claims, that's a very hard thing to automate for a chatbot, because at the start of that conversation can take many different twists and turns. Sure. And resolving a claim, for instance, a medical claim, you need a lot of different parameters. You need like doctor's notes. You need proof of eligibility. You need a lot of different pieces of data that are in disparate sources, and to try to automate that is a very tough task.
Well, okay, mine's slightly off topic here, but to put the myself in this weak-minded category here, put us at ease a little bit about the ghosts in the machine, that if you're teaching machines to teach themselves to do more things, and the AI stuff and all of that, we saw iRobot. Okay, Will Smith. I was about to make the iRobot. It's like super messed up. And is that where do you?
Are we heading that way, Tim? Are we going to die? Are robots going to take over the world? Please just answer.
Robots already taking over the world, man.
I'm going to put this in perspective and give you the non-Hollywood spiel.
Oh no, forget that.
The world's going to end, and we're all going to lose our jobs to robots. No, a computer is going to do what you teach it to do, and it's not going to go beyond that. If it could, then my job would be a lot easier. But I spend a lot of my time telling the computer exactly what to do, and in certain situations, exactly which parameters to sort of collect and then straight through process. So the reality is, machine learning isn't going to, or AI isn't going to do anything additional to what you teach it to do on a computer. And right now, it still can't do a lot of things. Like, it can't really handle a body of knowledge where a lot of human intuition skill is involved. Like, if I job shadow sometimes, and just a quick note on data science and being successful in data science, go to where the frontline workers are if you want to solve a business problem, because they'll show you exactly what the problem is with whatever system, app, or whatever website they're using. Yeah. So when I job shadow, claim adjusters, there is so much knowledge and human intuition involved in even simple, claim resolution. It's so much involved, so much knowledge, so many parties involved. You have to go to, the police. If it's like, I used to work in auto insurance, you have to go get the police report. You have to determine what's in the police report, because it's kind of unstructured. You have to look up vehicle information on this random third-party website. You have to enter in a bunch of information on your own internal systems. And you have to like cross-check all the time against different systems. So I will say, I wish machine learning could do more than what I'm teaching it, because then my job would be a lot easier.
So question, Tim. So let's move into kind of, so people watch this like, this sounds great. It's a little over my head, but it sounds great. Computers are going to take over the world. Sounds great.
Great. Totally.
How can a company, like, how do companies decide if they should get into this, right? Like, and then how would they get started? So if like we have a CIO, CTO watch this, like, man, that sounds great. ML, NLP, yeah, sounds great. Let's do it. Like, do all companies need to implement it? And I probably know the answer to that. And then if they do need to implement it, like, what are some key things from a business perspective that they need to be mindful of?
All companies probably don't need to implement machine learning, data science, AI, whatever you want to call it. I would say definitely explore it. If you think you're one of the companies that you don't think you need it, explore the idea. But a lot of companies today, they fail on data science because they decide one day, hey, we want to do data science. And then the very next day they go out and hire 5 data scientists without worrying about data infrastructure, data architecture. Like they don't build out the proper environment for data scientists to be successful. And in those environments, you'll see a lot of data science turnover. I'm sure all of you have seen that a lot. And I'm sure when you talk to data scientists who are looking for jobs or getting out of jobs, they'll say, this place just isn't ready for data science.
Yeah.
It's just like everything else. Bad data in, bad data out. Doesn't, the algorithms don't change the integrity of the data.
Ooh, here you go, Jake. Jake bringing the heat. Jake bringing the heat.
Mic drop, right?
We've seen lots of bad data the last couple of years.
Exactly. And there are some data scientists where you could bring them in an environment like that and they would thrive because they might be closer to what we might call like a unicorn. They can do the data engineering. They can lay that foundation. They can do the modeling. They can do the business strategy. They can communicate with the business, and then they can track success metrics to really then sell other data science business to their company.
So is it a complete mindset shift? So if we have hiring managers, CIOs, CTOs, VPs of engineers watching this, like, yeah, we want to do this. Like, is it a huge lift to get your data to a point where you can bring on data scientists and implement ML, NLP, and whatever acronyms else you want to throw at it?
It's a big lift if you're starting from zero. Like a lot of companies, they did their data infrastructure the right way before they even heard of data science. They knew that they had apps, for instance, that were very data intensive. So they knew they had to structure their data in a way that was easy to pull out, easy to manage, easy to maintain. And so, I've worked for companies like that where they said on day one, we want to do data science. And then the next thing they hired a bunch of data scientists because they already had data architects, database administrators on board. They already had data engineers. Even though they might not have been called data engineers, they were doing data engineering and ETL stuff. And those are the type of companies, that I think succeed the most is when because you can do data science the right way, right? There are a lot of companies doing data science the right way. They start slow. They don't start with those huge multi-million-dollar projects and fall on their face and then cause the business to doubt if it's ready for data science. Like they start with those $200,000 projects. Those are good projects to start with because usually from an implementation standpoint, they're easier to put into place in a process end to end. And now you have a foundation for how to deploy machine learning after the fact. So this is one of the mistakes I made early on at a place I used to work at. Is I made this very sophisticated data science model. We didn't really have a standard for how to deploy data science models. And that became one of our first use cases, is deploying this really sophisticated, really involved model. And it took forever to deploy it in a proper production environment because it was just too involved, too complicated. What I should have done in retrospect is started with a much easier model. Maybe I would have sacrificed a few points of accuracy. In the grand scheme of things, that doesn't really mean much. But it would have been easier to implement, and we would have had a good foundation on how to deploy data science models moving forward. Because that's a huge thing now. Is a company has a bunch of data scientists. They're all working with really cool sounding tools. They're using neural networks and all this stuff, but they don't have the what's called machine learning engineers or software engineers who understand machine learning or the machine learning lifecycle that can deploy and host these data science models.
We've seen, I don't know, I'm sure you've seen it more closely in your space, but we've seen companies, especially in the CRO pharma space, that have pivoted from being a CRO to being a data company, because I've run these clinical trials 10 million times over the last 20 years. We gathered the right amount of data, we've validated it, and we've built out whatever it is to be like, we can skip steps 1 through 4 of this clinical trial simply because it is the exact same if you use these exact same components. And here's the facts to back that up, which has been fascinating and ultimately made a lot more money for some of those companies when they made the investment to have the data integrity in the first place. Right. Otherwise, I think you could just sink so much money into hiring data scientists and not have any idea how it drives revenue back, or even how it makes you better insights for internal and external business cases. But I did want to pivot us into one thing, just in case there's some folks on here that wanted to be like, okay, if I want to just play around with this myself, as a software engineer, like, where do I start? I know there's like some like RPA can be like some low level automation stuff you can do, for business tasks. So I don't want to go that low, right? I want to go more software engineering stuff. Where do I start? Do you have any tools or tutorials, or like, hey, this is a really fun sandbox that you can set up, like anything like that?
I love this question. I would say start local. It's exactly what I did when I was trying to hone in on my data science skills, and then also trying to look for my first data science job. I didn't, whatever computer you have, it's good enough to do data science, and it's good enough to do projects that are then good enough to show on your resume and show to recruiters and show to hiring managers, right? Like, I would say start local, start with problems that you face every day. One of my favorite projects that I've worked on is called Achu. It's a way for me to track my son's allergies. Yes, exactly.
Oh, wait, that makes sense.
Right. It's called Achu, and it's a way for me to track my son's allergies, and then predict when he'll need his inhaler, so that when he was going to school.
Wait, real quick, you created that, or that's an open source project, or where is it at?
I created that and
cool.
I open sourced it, so it's on my GitHub page, it's on my LinkedIn, all of that. But it was a way for me, because he was pretty bad asthmatic for a while there, so it was a way for me to be able to track
Nashville.
Oh, absolutely, man, absolutely. So it would track his allergies and sort of what caused him to be sort of asthmatic on a certain day, or have episodes on a certain day, given the allergens, environmental data, weather data, all this data that we pulled in. And then if he needed his inhaler on a certain day, it would email his school nurse. So his school nurse could sort of get out in front of it, because once he has the episode, it could sort of knock him off track all day. And then more importantly, distract him from school, because a lot of times he would have to go to the nurse's office and miss a bunch of, school assignments. So that's just that's a project that I started doing when I wanted to hone in on my data science skills. And like, that was local to me. That wasn't a problem where I went out to a tutorial, found a bunch of YouTube videos. That was something I didn't know anything about. I knew about asthma from a human perspective. I didn't know anything about getting the data, doing the modeling, putting it in the cloud for other people to use. But then when you get that interest in something, and that deep interest, it's more of an incentive for you, and encourages you and motivates you to then go and work on that project and see it through to completion. And that's going to, starting on problems like that you care about, it's going to do way more for you than going to, Kaggle, or going to, some cookie cutter tutorial and working on projects like that, because you're just not going to care about the project. Like there's I'm not sure if any of you are aware, but like there's these boilerplate, data science problems, like the Iris data set, which categorizes different types of flowers, the Titanic data set, which tries to predict who will survive and who won't. Like these are, I'm not gonna lie, these are boring projects. I think they're good for like wiring things up and understanding how things work. But if you really want to impress companies, do projects that mean a lot to you, and then be able to translate that value when you're asked about it.
So,
Tim, go ahead.
No, go ahead, dude.
Tim, what's next? And sorry, I had a drop off for a second earlier, so you may have mentioned this. What's next in the world of machine learning? What are we waiting on, or what's the reason why we're not there for some of those things? Is it computing? Is it knowledge? Is it chips?
I think one of the things coming up, and it's already here for a lot of projects, is how to do more with less. Because everyone talks about big data, big data, big data. You know, a data scientist going into an organization, if they hear a business problem, the first thing they're going to ask is, how much data we have and where is it, and is it labeled or not? Like, do we already have the answers? I think that is going to transform more into, can we use off-the-shelf models that have been trained by the Googles, the Facebooks, the Amazons? Can we use those and tweak those models using transfer learning or other techniques to then be able to get a small data set from our company and update the model with the weights of our local problem, our company, and we only have to have like 1,000 records, and the model will be able to predict almost as well as if we trained that model from scratch. Because training a model, or I think more importantly, the bigger cost to do a successful project is trying to get the data, and especially trying to get the data when you don't really have the labels or the answers to the data. I think that's going to be next up and already here for a lot of the projects. I'm trying to do more on that at my current company at Unum, where we don't really have, for some projects. Some projects we have a lot of data structure, like there is structure. We have plenty of data. For other projects, we don't have as much data. So I'm trying to be more mindful of that and use off-the-shelf models where possible, and trying to take the approach of using not as much data, but instead using these off-the-shelf pre-trained models that have been trained on billions of records.
I mean, Google's been preparing for this forever.
Yeah.
You know, it's like they were just like, finally, Google Cloud now, and now you can have all of our data sets and our public data. I mean,
exactly.
Yeah.
So there's, and we'll wrap it up here with kind of a few more questions. And again, thank you for coming on, y'all. Thank you for watching. Had a bunch of comments that have come in throughout the show. If you have any questions for Tim, please throw them in the chat, add us, comment us. We'd obviously love to ask Tim. This is your chance to actually ask somebody who knows what they're doing something. So Tim, let me ask you this. This comment was a while ago. What's the difference between ML, NLP, and RPA?
Yeah, RPA, robotic process automation. So I would say robotic process automation by itself doesn't use machine learning and natural language processing.
Okay.
But I think connecting those techniques allows for a lot of different options. I'm more in the ML NLP space than the RPA space, so I'd be interested in what some people in the chat have to say about that. But I definitely see those as being very different techniques.
Okay.
Where RPA is more, you already know the parameters, you have the parameters, you don't really have to predict anything, and then you can straight through process that. Whereas machine learning, natural language processing, there's a predictive element there. You're dealing with uncertainty. But then when you marry those two together, I think you have a lot more options for trying to, deeply automate something.
So if somebody's, from a job seeker perspective, right?
Mm-hmm.
So I know we talked about open source things, open source projects. What are some maybe tips and tricks, other suggestions you would give individuals on the job search who are new in their career, and just some tangible things that they can, I don't know, pick up on, research, maybe not even in ML, NLP, but just in data in general? Like how would you recommend picking up these skills if you have no experience in these skills?
First tip, follow Taylor on Twitter. The dude is full of great insight on navigating the job market. After that, after you've gone to Twitter and followed Taylor, or on LinkedIn,
put your handle up.
I'm not doing that. Stop.
Do it. After you've done that, I would say do more and read less. This is a.
I love that.
And I wouldn't even say it's a problem, because I think reading is fine. I'm not saying not read.
Nah, reading's overrated.
That's because you know.
Once you hear something that you think, okay, I can apply that to my life, I can apply that to a project that I'm interested in, go do the thing. Like there's nothing stopping you. You don't need anybody's permission. Go to Google, figure out how to do it, and close the textbook. You'll get that. You'll read that later when you're trying to optimize it and make it better. But first, get that MVP thing out and show someone that this is valuable, and more importantly, that you're learning and learning exponentially. I think reading is great. I still crack open the textbook. I have a couple of textbooks right here. But that's when I'm like searching for something new. I don't really have an idea for a project in mind. But when I have an idea for a project in mind, I'm not touching the bookshelves. I'm going straight to Google, figuring out, I'm looking for the hello world example, and then I'm going straight to implementation.
I love that.
So good. The rise and the continued height of the information age, which I think even exacerbated, good or bad, in the last year, has led to so much information and so little action, and so everyone knows everything, but not know how to do it, so because no one's doing anything. Right. The ones who are doing things are the ones who are being successful right now. Right. So that application, I think, is so important. We talk about that too when it comes to like certs versus real world experience, or going to get another degree versus taking that job offer that's going to train you on the job with it when you already have a good foundation. It's the problem solvers are going to win. The ones who are going to do things are going to win in the end.
Absolutely. And one of the things that really helped me out when I was looking for that first data science gig was starting a blog. I started
let's
blog.
Talk about this. Let's talk, because we talked about this as well previously.
Absolutely. So I'll give my spiel, and then I'll let you sort of give your spiel on what you've seen in this sort of blog world. But I use mine as a process of learning. I'll give you a quick story. And this happened in Nashville, but I won't give any names. I was going for what I thought was my dream job. At my dream firm. I had the recommendations. I had the open source projects. When I got there, they were asking me about the open source projects. So I knew as soon as the company starts asking me about my open source projects, boom, who knows about those projects more than I do? I'm an expert in those projects because I created them. But I completely bombed every other portion of that interview. I completely fell flat on my face. It was embarrassing. It was demoralizing. And for the rest of that day, I cried and moped. But after that, I said, okay, this is what I want to do, because it was an NLP role a few years ago. I said, this is what I want to do. So I fired up the blog again, and I started blogging like crazy on anything NLP. Started, I'm a big rap music fan, so I started, analyzing the rap lyrics, pulling the rap lyrics, and really doing a lot of blogging and writing and learning. And I didn't go to a textbook and say, hey, what is this thing? I just went straight to the blog and started doing these projects and started publishing them to the world. And I learned more after that, failure than any other time in my career. Like that 6 months after that, I was like, man, I feel like I felt like I matured in dog years, just because I started out as knowing nothing about this thing, but I really wanted to do it. And then after 6 months to a year, I felt like I was ready for an NLP role.
That's it. That's awesome. All righty. Well, Tim, thanks for hanging, big dog. We appreciate it. We appreciate y'all. Thank you for tuning in. Alicia, Michael, Pia, Jarrett, Amy, Kathia, Faye, thank you so much for tuning in this morning to Unicorn Finders. Check out Tim's open source project. We've obviously linked it here. Connect with Tim. Tim Dobbins on LinkedIn. Tim, thank you again, man. And we'll send you a coffee mug.
Yeah.
All right. Heck yeah. Thanks, y'all.
Thanks, guys.
We'll see y'all next week, 10:30 Eastern, Thursdays.
Yeah.